Alright, hello again. This is the first time I've used Screencast-O-Matic. Little shout out there for free software where you can see me down in the little box down on the right, and then you can see what we're working on out here. And I can even get right in your face for a second if I need to. So yeah, we'll see if this becomes handy. We're doing 7.2 right now. We just talked about ratios. Let's see how well we can see this here. Alright, ratios and rate and unit rate. A ratio, remember, or ratios, is when you compare one value to another value. So I have 5 elephants to your 2 elephants. Or I have 10 elephants to your 4 elephants. That's a ratio of 5 to 2. And you can write a ratio like that, right? And you can actually write it like that. It looks like a fraction. A rate is a ratio that is comparing two values of a different unit. So instead of elephants to elephants, we're going to say 5 cougars to 2 turtles. So at the, I don't know, San Diego Zoo, they have a whole bunch of cougars and a lot of turtles too. This is obviously not true, but let's say the ratio of cougars to turtles is 5 to 2. So if they have 6 turtles, that's times 3. That means they have 15 cougars, right? So you're comparing 2 different things, cougars to turtles. Or there is 100 girls at this school to the 37 boys. The ratio of girls to boys is very high. And I have friends in high school that would honestly, they would choose what school they were going to based on the ratio of girls to guys. If there was a high ratio of girls to guys, that was a good place to be, because it gave them a better chance of being able to date the cute ones. All right, unit rate. This is when the rate has a denominator of 1. Okay, so miles per hour. If you're going 30 miles per hour, one way to write that is 30 miles to 1 hour, right? Or 30 miles to 1 hour. If you're comparing it to 1, that becomes a unit rate. 30 miles per hour, or 8 grams of sugar per 1 serving. Okay, that's where we've been. Now, today we're talking about proportions. Proportions. What are those? That is when, well, let's not get ahead of myself. Let's take a look at this rhinoceros beetle. Pretty cool. I hope you have your book with you, because you can see the picture a lot more clear than in this video. But rhino beetle here. An adult rhino beetle weighs only 0.2, this is awesome, 0.25 ounces, but can carry about 446.25 ounces. So it weighs only 0.5 approximately, and it can carry 445, almost 446 ounces on its back. If a person were as strong as a rhinoceros beetle, how much weight could a 100-pound person carry? Oh my goodness. So to solve this, we're going to use a proportion. Proportion is an equation that states 2 ratios are equivalent. So let's try this out. Let's do the beetle's weight, 0.5. I'm gonna simplify it, okay? And I need to move this up. I have this zoomed in. The beetle's weight was approximately 0.5 to the amount of weight it could carry. It was about 445. Okay, if you were doing this problem, obviously you would use the specific numbers, but just to simplify it, I'm not. So 0.5 is how much it weighs to how much it can carry. Well, a proportion equates 2 ratios, meaning it sets this ratio equal to the ratio of the human. So the human weight, do we know the human weight? Yeah, we do. We're talking about a 100-pound human in this problem. The question is, if you weighed 100 pounds and you were as strong as a rhino beetle, yeah, that'd be cool. How much weight could you carry? So this ratio of beetle weight to how much it can carry is going to be the same as your weight to how much you can carry. So how do we solve this problem? We use, in fact, actually, before we get there, you can set up a ratio like this. Same thing, okay? This is the weight it can carry and the weight of the beetle to how much weight you could maybe carry to your own weight. So let's work with this one right here, okay? If I were trying to solve for this, and this is weight you can carry, so I'm going to make this a C, the weight you can carry, okay? How could we get C by itself? By the way, 445 divided by 0.5 is actually 445 divided by 1/2. Dividing by 1/2 is the same multiplying by the reciprocal, which is 2, so this simplifies to 445 times 2. In your head, 890. Okay, 890 equals that. Now, whoop, there we go. How can I get C by itself? Well, I can just multiply both sides by 100, right? Multiply by 100, both sides, and those hundreds cancel out. And I've got now 89, 0, add the 2 zeros for the 100. Can you see this? Equals C. How much can you carry? If you weighed 100 pounds, you were as strong as a rhino beetle, you could carry 89,000 pounds. I don't know about you, but I think it'd be pretty awesome to be able to lift my car and just kind of hold it up over my head and just look and see what was wrong. 89,000 pounds, that would be awesome. Okay. Proportion. That's how proportions are useful. Now, notice this says the B here and the D, these denominators, they can't be 0. You can never have a denominator that's 0. That's an error, right? So let's take a look. Well, actually, example 1, we already did. Example 1 was this beetle problem. We did it just like they did. I'm going to move over here and see how, yeah, let's talk about cross products for a second. There is a trick to solving a proportion that you may have heard of before. It's called cross multiplying or using cross products, okay? Now, the way that we did it, let me show you here again. The way that we did it was to multiply both sides by 100. I simplified this side, then I multiplied both sides by 100 to get C. There's actually a cooler way, and a way that you need to learn because you're going to have to know it in case, check this out. In this case, what if you set up your proportion like this, where you've got that on the bottom? I can't divide both sides by 100 because then I'd be left with 1 over the question mark. Do you see how that would work? 1 over the question mark if I divided both sides by 1. So if you've got the variable in the denominator, that's weird. So this is where cross products comes into play. And it's really quite simple. All it means is if you got some number A to some number B and C to D, we've got a proportion set up here. This whole thing, by the way, is a proportion. One ratio equals another ratio. Cross multiplying means that A times D is always going to equal B times C. Okay, that's what they have right there. A times D equals B times C. Now, how is that helpful? I'll show you. So we'll look at this. 3/4. Is 3/4 the same as 9/12? Yeah, 9/12 simplifies to 3/4, right? So, oh, my wife is calling me. Let me pause this for a second. Let's see if that works. All right, I'm back. You guys are getting a glimpse into my my life here. So, 3/4 is the same as 9/12? 9/12? Yes, it is. These fractions are the same. We could also look at these like they're ratios, right? Now, did you notice that if you do 3 times 12, if you cross multiply, that's 36? 4 times 9 is also 36. All right, big deal. How is that going to be useful? Well, let's check it out. Example 2 right here. if we've got a ratio of 6.8 to 15.4, and we know it's equal to 40.8 to something else that we don't know, then multiply across 6.8m equals 15.4 times 40.8. Simplify that side, divide by that, 6.8, and you can figure out what m is, 92.4. All right, not so bad. Let's take a look at this last example, and then I'm going to try to do a couple example problems with you, but because I only have the trial version right now of this screencast software I'm using, I only got 15 minutes, which means I've got 4.5 left. So let's take a look at the scale model. Here's a big old strawberry at some town that is really into their strawberries. Okay? They made this big model off of a small actual strawberry. Okay? So this is called a scale model. They took that small little strawberry and they scaled it up big to make that, I think that's on top of a building somewhere. So the dimensions of a scale model are proportional to the dimensions of the actual object. They are proportional. Okay? The dimensions of this strawberry is obviously not the same as the dimensions of the little strawberry that you can hold in your hand. Those dimensions are the same, but they are proportional. Okay? The scale gives the relationship between the model's dimensions and the actual object's dimensions. All right, so let's look at this. Strawberry Point, Iowa has a strawberry sculpture that is 15 feet tall. If the scale of this model is 10 feet to 1 inch, how tall was the original strawberry? Okay, let's use our own heads for a second before looking into the book's head. So the scale is 10 feet to 1 inch. That scale, that ratio, is the same as 15 feet to, and what we want to know is how many inches tall was the original strawberry. 15 feet is the sculpture. I'll put sculpture here just so you can see that. Sculpture. And down on the bottom, because 10 feet, yeah, down on the bottom we have the actual strawberry. So if the sculpture is 15 feet tall, and what would the height be, h, of the actual strawberry if the scale is 10 feet to 1? Well, you have to set up a proportion. This ratio is the same as this ratio. I cannot put h over 15. Okay, because this h is going to be in inches. You got to keep the same units on the same line. Okay, 10 feet to 1 inch, 15 feet over well, however many inches our actual height of our little strawberry is. So let's just cross multiply. 10 times h equals 15 times 1, which is just 15. Divide both sides by 10 to get rid of that guy. H equals 15 divided by 10 simplifies to 3 over 2. Does it not? Yes, it does. 3 over 2 is the same as 1.5. So the height of our original strawberry is 1.5 inches. Oops, 1.5 inches. Okay, let's see if I got that right. Height, 1.5 inches. Cool. I got 1 minute to maybe do an example problem here. Let's see. Let's go over to here. Tell whether the ratios form a proportion. 1/2, is that the same as 2/5? Is 1 times 5, which is 5, the same as 2 times 2? Nope. There, that was easy. Number 9 is a big fat no. It is not a proportion. If it was a proportion, the cross products would be the same. You getting that? All right, so on these, you're going to solve a proportion. You're just going to do your cross products method.